Okay, this is the last video for Chapter 5. It covers Section 5.4. It'll definitely be the shortest. Okay, this last section in Chapter 5 has questions about means. Okay? It turns out that the mean of almost any distribution is distributed according to the normal distribution. This is what makes the normal distribution so important. Questions about probability and the mean of almost anything can be answered using the normal distribution. From here on out, whenever you get a normal distribution question, you need to check to see if it is about a mean or about an individual value. If it's about an individual value, then you'll do what you did in 5.2 or 5.3, depending on whether you're being asked for a probability or a value. If it's about a mean, then you need to make only one and only one adjustment. All right? Divide the standard deviation that you were given by the square root of the sample size. Everything else stays the same. Okay? So your only one adjustment. Divide the standard deviation that you were given by the square root of the sample size. Everything else stays the same. All the stuff in the section in 5.4 about the distribution of the sample means is just to make sure you understand that the means themselves are distributed normally. In other words, if you view the means themselves as data values in a distribution, that this is a collection of means from other distributions. This can get kind of confusing. Fortunately, using this information is simply a matter of dividing the standard deviation by the square root of the sample size, and then doing the same things we did in 5.2 and 5.3. All right, so let's try some questions here. You'll see what I'm talking about. All right, these are both questions are taken out of our textbook. Salaries. The population mean annual salary for an environmental compliance specialist is about $63,500. $63,500. All right. A random sample of 35 specialists is drawn from this population. All right. So the sample, right? Random sample of 35 specialists. That's our sample size. What is the probability that the mean salary of the samples is less than 60,000? Assume the standard deviation is 6,100. Okay? Now, so the only adjustment we're going to need to make, we'll do this just like we would have done one in 5.3 or 5.2 rather. This is a probability question, 5.2. Except that we're going to have to divide this standard deviation by the square root of the sample size. Now, if you look on your calculator, you will see just up one button and over one to the left, there's the x squared up from the 7. If you look at the 7, just go diagonally up and one and to the left. There's the x squared key, and the second function on that is square root. That's what we're going to use. Okay? So what I'm actually going to do is I'm actually just going to put it all in the normal CDF function. So we can go normal CDF. What we're looking for is that the mean is less than 60,000, right? So this is one of those where there is no lower limit, right? Actually, and in this case, because this is 60,000, I'm going to use an extra 9 on my fake infinity. So I'm going to use 6 9s for minus, as I stand in for minus infinity. Then my upper limit will be the 60,000. The mean we've got is the 63,500 that they gave us. Now for the standard deviation, remember we need to take the standard deviation and divide it by the square root of the sample size. So what I'm literally going to do is this, is we will do 6,100. I'm going to hit the divide key. I'm going to hit the square root key. And we'll type in the sample size of 35. Now when you hit the square root, it's automatically going to put an open parenthesis in here with it. Okay? So we'll have to close the parenthesis on the square root and then close the parenthesis on the normal CDF command. Okay? So that's what I'm going to do. Alright, so let's see what we get. So DISTR, normal CDF, negative 999,999, comma 60123, comma 63500, comma. Now 6100 divide, do the square root key, right? So that's the second square root. And you'll notice it put a parenthesis in for you after the square root symbol. So we're going to type the 35, close the parenthesis on the square root, close the parenthesis on the normal CDF, and hit enter. And the answer it gives us is 3.439, bunch more decimal places, and then out here it says E -4. Alright, well, you have to be careful now because occasionally this is going to happen. When you see this on the end, what this means is this number here times 10 to the -4th. You remember your scientific notation? It means we've got to take this and move it 4 to the left. So that means our answer here is 0.123, and then say 34. It probably asked for it just to 4 decimal places. It would have been 0003, probably in my math lab. So my math lab probably would have been looking for that is the answer. All right, let's do the next one. Lumber cutter. Your lumber company has bought a machine that automatically cuts lumber. The seller of the machine claims that the machine cuts lumber to a mean length of 8 feet. All right. Mean equals, everything else is in inches, so we'll use 96 with a standard deviation of 0.5 inches. Assume the lengths are normally distributed. You randomly select 40 boards, so there's our sample size, 40, and find that the mean length is 96.25. A. Assuming the seller's claim is correct, what is the probability that the mean of the sample is 96.25 inches or more? So what we're looking for is the probability that it's greater than 96.25. Okay. Well, greater than or equal to. But really in the normal distribution, the or equal to doesn't matter. Alright, so we're going to do the same kind of thing we just did before. Now, this is a greater than, right? So we're going to use, there is no upper bound on this one, right? If you think in terms of our picture here. We'd have something like this heading out to infinity. It's a greater than, so there's no upper. So I'm going to use the 5 nines or the 6 nines as a stand-in for infinity. So normal CDF. So it's a greater than 96.25, so that's the lower bound. My upper bound, I think I'm just going to stick with 6 nines from here on out since we had one come up that I really needed all 6 nines. The mean is 96. And the standard deviation now, remember this is about a mean, right, with a sample size. So what we have to do is the original standard deviation divided by square root sample size. Put in parentheses to close the square root and another one to close the normal CDF. Alright. Second DISTR, normal CDF, 96.25, comma, 6 nines, comma, 96, comma, 0.5 divided by second square root 40. Close the parenthesis on the square root, close the parenthesis on the normal CDF, and we get another very small one. Alright, this one says 7.8, bunch more decimal places, E -4. So by the time you move this 4 times, we end up with 0.000, and then this would round to an 8, is the kind of answer that my math lab would probably be looking for. Okay, now these are not all going to be small like this. I picked these 2 examples small because I often get, I've noticed that students miss them when they have this E notation on the end of it, so I wanted to go through and do that twice. Just like before, you know, some of them will be big probabilities, some of them will be small. This is the adjustment you make, alright? So from now on, anytime you get a normal distribution question, you have to look and see if it's about a mean or about an individual value, and if it's about a mean, then just like we did here, you need to remember, just like this right here, You need to divide that sample size. You need to divide the standard deviation they give you by the square root of the sample size. All right, that's it for this.